Shall we start, madam? Meanwhile, rest of the participants also will join.
Yes, sir, we can.
Thank you, ma'am.
So shall I directly start, sir? Shall I start, sir, now?
1 minute, madam.
Okay, fine. Yes, sir, we can. So shall I directly start, sir?
Yes, madam.
Let's start, sir, now.
1 minute, madam.
Okay, fine. Yes,
Ma'am,
sir.
I think there is some echo, madam.
Hello.
Hello.
Yes, sir.
1 minute, madam. So good afternoon, all of you. This is Dr. K. Kiran Kumar, Vice Principal and Head of the Department of Computer Science and Engineering. On behalf of Telepathy Institute of Engineering and Technology, Department of Computer Science and Engineering, I welcome all the participants to this webinar on satellite communication. Coming to the college, CIET was established in the year 2007 under the leadership of Sri Y.V. Anjal Garu, former MLA. The college was located in the capital region of AP Amravati in the Guntur city. Ours is an autonomous college under Acharya Nagarjuna University, accredited by NBA, NAC with A grade, and UGC 2F. We offer both UG and PG courses in the college. Coming to the department, CSE is the active department in the college. We have conducted more than 50 events in the pandemic period, which includes FDBs, workshops, webinars, STDBs, seminars, conferences, etc. Till now, more than 30,000 participants got benefited from the events which we have conducted from May 2020. Coming to today's webinar, the resource person is Dr. Swaminarayan Priya Ramesh Bhai, Dean, Faculty of IT and CS, Professor and Director, MCA Department, Principal and Professor, Parul Institute of Computer Application, Parul University. And coming to the ma'am's profile, so ma'am completed her PhD from Ganpat University, MCA from Sardar Patel University, BSc from Sardar Patel University. Ma'am, under the guidance of ma'am, 5 members got PhD awarded, and a total of more than 15 years of experience is there for ma'am, and she has she has acted as a Dean, Faculty of Information Technology and Computer Science in Parul University, Director in Parul Institute of Engineering and Technology, Principal in Parul Institute of Computer Application, Professor and Head of MCA Department, Institute of Science and Technology for Advanced Studies and Research, Head of MCA Department, Institute of Science and Technology for Advanced Research, Studies and Research, Associate Professor, Assistant Professor, and Head of the Department at N.V. Patil College of Pure and Applied Sciences. Ma'am has 3 funding projects on her name, and she has done 54 publications till now, and she has presented papers at different national and international conferences, and she has attended more than 40 workshops, conferences, STTPs, and ma'am delivered 27 expert lectures till now, and she has published 5 books, and research papers she reviewed is 7, and for different events ma'am has acted as a judge also. Thank you so much, ma'am, for accepting our request and coming as a resource person for this webinar. Your experience is very vast, and it will help our students and all the participants to gain some knowledge on satellite communication. Thank you so much, madam. Over to you.
Yeah, thank you, sir. Thank you so much for introduction. So the students, they are from engineering, right? CSE
yes,
engineering.
Yes, ma'am.
Okay, and they are from which semester, sir?
Different branches they are there, madam.
Okay, they are from different branches.
Yes, madam.
Okay, fine, not an issue, sir. Let me share my screen.
Okay, madam.
Okay, very good afternoon to everyone. So, dear participants, today I would like to give some brief introduction about wireless communication and especially in the satellite communication. Okay, so now you already know, right, that the communication. So, communication that is very much important, and especially in the field of computer science. Whenever you want to perform any communications, we should be having some components. Like we should be having the clients, computers, server computer, then transmission media, NIC card, interconnecting devices. Even we have to install network operating system on server, operating systems on the client machines, right? So these are the few components that are required for establishing any computer network. So first we discussed what are the two types of transmission media that we can use for our communication purpose. So first one, that is guided media and unguided media. So guided media is nothing but the wired media and wireless media. So in a guided media, there are three mainly examples. One is a twisted pair, coaxial cable, and fiber optics cable. So how we can differentiate the guided and unguided media? So the first thing, in a guided media, there should be some kind of a physical medium. Through that physical medium, we can transfer data in the form of electromagnetic energy or in the form of electromagnetic voltage level. But in case of unguided media, we don't need any kind of physical media, right? So that's why it's unbounded. So without using any medium, means without using any physical medium, we can transfer data from source to destination. Now, as I said, there are mainly three examples for the guided media: twisted pair, coaxial cable, and fiber optics cable. So twisted pair and coax both used means both are made up of copper wire. And in the copper wire, we can transfer data in the form of electromagnetic waves or in the form of current. But instead of that, suppose our devices are connected with the help of fiber optics cable. Then fiber is made up of either glass or plastic, and in which we can transfer data in the form of light. Now, students, this is the figure of twisted pair. So in case of a twisted pair, we can divide it into the two categories. One is a shielded twisted pair and second is the unshielded twisted pair. Now, how we can differentiate these two? So in an unshielded twisted pair, there are only two layers. This is the actual cable. That cable is covered with the outer jacket on it. But in case of a shielded twisted pair, there are more than one layers, more than two layers. That means this is our cable. This cable that is covered with the inner jacket, or that inner jacket, it's covered with the outer jacket. So that means what? Here there is one more, there is a one additional jacket. And as and when we increases the total number of layers, it increases the strength of a cable, even it increases the data rate also. So as per our requirement, we can use either STP cable or UTP cable, right? So this STP cable, that is better for security purpose, for data transmission, but because of one additional layer, it increases the cost as well as it increases the weight also. So that is the drawback of a shielded twisted pair. Now the second one, that is coaxial cable. So coaxial cable in which the total number of layers are more compared to UTP and STP cable. And because of that reason, the coaxial cable, the performance, the data rate provided by the coaxial cable, it's better than STP cable and UTP cable. And normally STP and UTP, these two are used in case of local area network. And coaxial cable, that is widely used in cable television network. And the third option, that is fiber optics cable. So as I said, the fiber optics cable, it's made up of either glass or plastic. And in the fiber optics cable, our data transmissions format, it would be in the form of light. So whatever informations we are having, that informations we need to convert it in the form of light, and that light beams, they travel through the fiber optics cable. But whenever we are transmitting through the fiber optics cable, at that time, we need to convert that signal in the form of light. And for that light conversion, we have to use special kind of device, and that device is either LED light or a laser beam. So that LED or laser beam which converts signal in the form of light. And once we convert it in the form of lights, then that light beams travel through the transmission channel, travels through the fiber optics cable, and again at the destination's end, we have to convert that light to signal, and that task can be done with the help of photodiode. So we have to use two additional interfaces whenever we are transferring the data through the fiber optics cable. This kind of interfaces are not required in case of coaxial cable and UTP and STP. Now, this is for fiber optics cable. In the fiber optics cable, propagation mode. Propagation mode means what? It's nothing but how we can transfer data from source to destination. That is known as a propagation mode. So in a propagation mode, you can see there are two types of propagation mode, single mode and multi-mode. In a single mode, the diameter of core part, it's very less, means it's very small diameter. And in case of multi-mode, the diameter is more compared to single mode. And because of a bigger diameter, we are able to transfer more number of light beams through this multi-mode fiber optics cable. Now, again, this multi-mode fiber optics cable, means propagation mode, it can be further divided into two subcategories. One is a step index and second is a gradient index. Now, in a step index, you can see in this figure, this white color part that is known as a core part, and this core part that is covered with the cladding part. The sky blue color part that is known as a cladding part. And in a core part, the density of core, it remains constant. And because of the constant density inside the core part, signal travels in a straight line, right? So you can see this is a light beam. This is the first light beam. It travels in the upward direction in a straight line. But from the edge of core and cladding, the signal is reflected back. Why? Because the density of core and density of cladding, it must be different. So from the edge between core and cladding, the signals will be reflected back. And from the opposite side, signals will be once again reflected back, and finally it reaches to the destination. So that kind of mechanism that is used in a step index. But what is the problem with the step index? For example, suppose I have transmitted, let's say, total 4 beams. In this figure, there are 4 beams: beam 1, beam 2, beam 3, and beam 4. Now, whenever we are transmitting different beams at the different angle of incident, at that time, the angle of reflection will be different for each beam. And because of that reason, the total number of bounces to reach at the destinations, that would be different. You can see, suppose you consider light beam number 1, right? So this is the first bounce, this is the second bounce, and this is the third bounce. That means this beam, it wants total 3 bounces to reach at the destination. Now we consider the second beam. So this is my second beam. So this is my first bounce. And after completing the second bounce, that signal, it reached to the destination. That means each and every beams they need different number of bounces. You just consider the fourth beam. So fourth beam, it travels in a straight line. So there is no any bounces. So what is the problem? Each and every beams, they need different times to reach at the destination. And here we are using, means we have to reassemble all the beams together for creating original message. And because of that reason, it is always affected by the propagation delay problem. Okay, so whenever we want to transfer any accurate or any precise information from source to destination, at that time, the step index is not advisable, right? But instead of that step index, if we are using a graded index, so in the graded index, what happened? Instead of transmitting a signal in a straight line, signals are transmitted in the form of sine waves, right? So whenever we are transmitting a multiple light beams from a source end, then all the signals, they will be transmitted in the form of sine waves. And the total time required by each light beams, that is almost same. So there is no any problem of propagation delay. But again, in case of graded index, the density of core part, it is not fixed. Okay, so whenever the manufacturer manufactured this kind of a graded index, it should be manufactured very, very precisely, very, very accurately. Otherwise, it creates a problem. And because of that accuracy level, it increases the cost of graded index. Okay, so as per our requirement, we can use either step index or a graded index. That means if you want to transfer a data very accurately, very precisely, then we should go with the graded index. Otherwise, we can use step index. But in a single mode, we can transfer very limited number of beams, and that's why the data rate is less compared to multi-mode propagation mode. Now, fiber optics cable. What are the benefits of fiber optics cable? Because there are three kinds of a guided media: twisted pair, coaxial cable, or fiber optics cable. So what are the benefits of fiber optics cable compared to twisted pair and coaxial cable that are given here? So the first benefit, the first advantage, that is very high bandwidth, right? So in fiber optics cable, as I said, we transfer data in the form of light. Okay, and light, it travels at the speed of 3 lakhs kilometers per second, right? So we can achieve a very, very high data transmission rate in fiber optics cable compared to twisted pair and coaxial cable. So that is a first advantage. Now the second advantage, that is less signal attenuation. Attenuation means what? It's a loss of energy. So when the signal travels, then signals becomes weak, and we need to increase the strength of that weaker signal. And for that, we can use either amplifier or repeater. So if we are using digital communication, then repeater is used for amplification. And if we are transmitting data in the form of analog signal, at that time amplifier is used for the for increasing the strength of that signal. So if we are using a fiber optics cable, then signal can easily travel for 50 kilometers. That means after every 50 kilometers, we have to install one repeater. But instead of a fiber optics cable, if we are using a twisted pair or coaxial cable, then after every 5 kilometers, we need to install repeater. That means what? For example, suppose I want to transfer my data for 100 kilometers distance, right? So I need, means if I connected my devices with the fiber optics cable, then I need only one repeater. But if I have used either coax or TP, at that time, I should use total 19 repeaters. Okay, so this is the benefit of fiber optics cable. One more benefit, that is immunity to electromagnetic interference. Now, as I said, in twisted pair and coaxial cable, we are transferring data in the form of electromagnetic waves or electromagnetic voltage. Now, this is the electrons, and electrons is having negative charge, and that negative charge is always attracted towards the external positive charge. And because of that reason, it creates an interference problem. But in case of fiber optics cable, the light data are transmitted in the form of light. Light is nothing but photons, and photons is chargeless, right? And because of a chargeless property, it's never attracted either towards positive or negative. Okay, so that is the means it is not affected by the external interference problem. So that is the benefit of fiber optics cable. Now the next benefit, resistance to the corrosive material, right? So corrosiveness, that is always affected in case of copper, right? But here we are using glass or a plastic, so it is more resistant to corrosive materials. Now lightweight. So fiber optics cable, it's very lightweight compared to copper cables. So these are the benefits of fiber optics cable. Now what are the disadvantages? So first disadvantage is, that is installation and maintenance, right? So for installations and maintenance, we need expertise, right? So expert people or trained people can only install and maintain the fiber optics cable. This kind of expertise is not, much expertise is not required in case of twisted pair or coaxial cable. Second disadvantage, it's unidirectional. Unidirectional means fiber optics cable transfers data only in the single direction. So if we want to perform a bidirectional communication or a two-way communication, that means we have to use total 2 fiber optics cable. So this is the second disadvantage. And the third disadvantage, that is cost. So fiber optics cable, it's expensive compared to twisted pair and coaxial cable. So these all are about the guided media, means wired media. Now the next category of transmission media, that is wireless. So wireless communication, that is used whenever the installation of fiber optics cable or twisted pair or coaxial cable, if it is not feasible or it's very difficult, at that time we can use wireless communication. That means, for example, suppose we want to perform any kind of communications in mountain, in jungle. Okay, so at that time it's very difficult to install a fiber optics cable in mountains and jungle. So we can use wireless communication. And in the wireless communications, no need for any kind of physical conductor, right? So, but there is a drawback of wireless communication. The advantage is no need of any cable. Without any cable, we can perform communication. So data will be propagated through water or through air, right? Now, drawback of wireless communication. That means the security. That is a major problem with the wireless communication. Because if anyone is having some device which is capable to receive our data, then the data may be hacked. Data may be received by anyone. So because of that reason, in case of wireless communications, we have to execute, means we have to implement some kind of encryption algorithm for secure data communication. Otherwise, data may be hacked by any hacker. So that kind of additional efforts we have to put in the wireless communications for the security purpose. And the first wireless communication, it was started in Hawaii Islands, because in the all the Hawaii Islands, they are separated by the Pacific Ocean. And at that time, before one century, at that time it was not possible to install a fiber optics cable under sea water, and that's why they first time used wireless communication in the Hawaii Islands. But nowadays, the fiber optics cable has been already installed under Pacific Ocean, but earlier it was not possible. So, as I said, this is the transmission media, guided media, unguided media. In the guided media, twisted pair, coaxial cable, and fiber optics cable. Now, wireless media. So, in the wireless media, there are many examples are there. So, first example, we can use a Bluetooth. But the drawback with the Bluetooth, it's always used for the short distance, right? Then we can use the infrared also. But infrared, that is used in the remote control. Right? We can use millimeter also. So infrared or millimeter kind of waves, it can be used for short distance. Now, second is a radio waves. Radio waves, that is also used for the communication, right? But again, it's always one-way communication. It's unidirectional communication. And the radio waves are not much suitable for the data communication. Then the next is microwave communication. Microwave communication, that also used. Normally it is used in the mobile communication, but the microwave communication, it is having the one property, it is a line of sight. That means if the sender and receiver both are not aligned with each other, that means if there is any obstacle between sender and receiver, then microwave systems will not work. Next one, satellite communication or a cellular communication. So it can be used for the long distance communication. So these are the examples of guided versus unguided transmission media. Now, this is the electromagnetic spectrum. Now we can see in the electromagnetic spectrum, this is the range for a this range can be used for the communication purpose, 10⁻⁴ to 10⁻�XVI, right? Now, within this range, actually this figure is the expansion of this, expansions of this range. It's 10⁻⁴ to 10⁻XVI. Now, in this figure, you can see this is the range for twisted pair, right? So, twisted pair, it's a hertz is for 10⁻⁴ to 10⁸. But coaxial cable, it is having more number of layers, right? It is because of a more number of layers, we can achieve more data rate. And its bandwidth, its frequency range, it's for 10⁵ to 10⁸8.9. Now, this is the AM radio. This is for FM radio. So these all are same as the data rate of coax as well as twisted pair. And this is the frequency range for television. And this is for satellite communication. And this is for terrestrial microwave communication. Now we just compare the fiber optics cable with all the guided and unguided transmission media. So the maximum range, it is 10⁻⁻10.5 hertz. But here the range for fiber optics cable, it's 10⁻⁴ to 10⁻⁵. That means the fiber optics performance is far better compared to all existing guided and unguided transmission media. Right? Now in this figure, you can see 10⁻⁻16 onwards, we can get a very good data transmission rate in case of X-ray and gamma ray. But still, we are not using X-ray and gamma ray for the communication purpose. What is the reason? The main reason is it's very hard to produce the signal. Even the modulation task is very difficult, and the X-ray and gamma ray cannot propagate through the wall. And it's very dangerous for any living things. And because of these three reasons, X-ray and gamma ray, they are having a higher frequency range. Still, we are not using it for the communication purpose. Now, propagation type. So, in case of unguided media, there are different kinds of propagation types that we can use for communication. So, mainly there are three propagation: ground propagation, sky propagation, and line of sight propagation. So the first type of propagation, it's a ground propagation. So in the ground propagation, you can see this is one of the tower. It's a sending antenna, and this sending antenna, it generates some signal, and this antenna, it generates low frequency signal. And whenever we generate a low frequency signal, then that signals are omnidirectional. That means it transmitted in all the directions. And this signals always follows the curvature of the earth. And because of that reason, it is also known as a ground propagation, or it is known as a surface propagation, because it follows the curvature of the planet. And here, the total number of distance covered by the signal, it depends on the strength of the signal. If the signal strength is more, then it can cover more distance. If it is less, then it covers limited distance. So based on the capacity, based on the strength of distance, we can decide that how much distance can be covered by that surface propagation signal. And the example of ground propagation includes submarine communication. And second example, it's a long range radio navigation. So submarine propagation, submarine communication, and radio communication, they are using ground propagation. Second type of propagation, it is a sky propagation. So sky propagation means what? In sky propagations, they used high frequency radio signals, and high frequency radio signals always travels in a straight line, and it travels into the upward direction. But from this edge, from the ionosphere, the signals will be reflected back. So this is a sending antenna. So sending antenna, it sends the data into the upward direction. From the edge of ionosphere, signals will be reflected back, and finally it is received by the receiving antenna. So this is known as a sky propagation, and this sky propagation, that is used for the long distance communication, right? And we can use the sky propagation in satellite communication. The third category of propagation in wireless communication, that is line of sight propagation. And in the line of sight propagation, it uses very high frequency signal. And this very high frequency signals also travels in a straight line. So you can see, this is the figure in which this is the sending antenna, this is the receiving antenna. So sending antenna, whenever it sends the data, there should not be any kind of obstacle between sending antenna and receiving antenna. Because if there is any kind of obstacle, then the very high frequency signal cannot penetrate through that obstacle. Okay, so signal will be reflected back. So we have to take care that there should not be any kind of obstacle. So what we can do, how we can cover more and more distance? By increasing the height of tower. Okay, as and when we increase the height of tower, then we can overcome the obstacle issue. Okay, but again, there is always a limitations on the height of tower. Okay, so sky of propagation means line of sight propagation, that is used in the microwave communication. And because of this line of sight property, the microwave communication, that is used for the limited distance. We cannot perform country to country communications by using a microwave, because there is always some kind of obstacles. Okay, so the condition, there should not be any obstacles between sending and receiving antenna. Now, as I said, there is a limitations in microwave communication, and that's why the satellite communication, it is always used for the long distance. As and when there is no possibility of a microwave communications, for example, suppose we want to transfer data from India to, let's say, Russia, Okay, now between India to Russia, there is a Himalaya. Okay, so what we can do, we cannot use the microwave communication, because whatever the antenna we install in the India and the antenna which is installed in the Russia, there is a Himalaya is an obstacle between these two towers. So we cannot go with the microwave communication. So at that time, we can install one satellite. So satellite is always used for the long distance communication. And sometimes what happens in some kind of undeveloped part, undeveloped area, whenever the installation of the tower, microwave tower, if it is not possible, then also we can go with the satellite communication. But again, in the satellite communication, it should be in a line of sight. That property is required, but we can use the sky propagations also. So sky propagation means what? From the Earth station, we can transfer data to the satellite. And from the satellite, we can transfer data to the, means in the downward direction, we can transfer data to the Earth station. So we can cover more distance, we can cover a long distance. So that is the main advantage of satellite communication. Now, in a satellite communication, as I said, the line of sight propagation that is required. But we are having the two types of satellites. You already know. We can use, means the real satellite is already there. Moon is the real satellite, right? Still, why we are using artificial satellite? So the main reason, in case of real satellite, the distance between Earth to Moon, that is always fixed. It's almost 384,000 kilometers. That means whenever from the Earth stations we are transferring any signal, then that signal has to travel for 384,000 kilometers distance, right? But in case of, means instead of that, if we are using artificial satellite, so as per our requirement, we can install a satellite at the height of 1,000 kilometer, or at the 1,500 kilometers, or at the height of 35,000 kilometers. So as per our requirement, we can install a satellite into the some specific orbit, and it cannot be possible in case of real satellites. And that's why we always prefer artificial satellites for the communication purpose. Now in this figure, you can see, as I say, the distance between Moon and Earth, this is 384,400 kilometers. That means what? For example, suppose I want to send some message, then my message has to travel for 384,000 kilometers to and fro. Okay, and while the signal is traveling this much distance, then signal becomes weak. So we have to install some kind of a repeater. Now, satellite orbit. Satellite orbit, what do you mean by orbit? Orbit is nothing but it's a specific path in which the artificial satellites around the Earth. Okay, so there are two types of orbit that we can use for communication for installations of satellite. The first one, that is equatorial orbit. The second one, it is a polar orbit. And this orbit, it is known as an inclined orbit. So whenever we install any satellite, then this orbit is fixed for that satellite. The satellite should not move out from its orbit. Next, period. Period of satellite means what? The total time required for any satellite to complete a single cycle, to complete a round around the Earth. That time period, that time is known as a period of satellite. Now, one of the German mathematician named Kepler, and Kepler has proved that how much time required by any satellite to complete a one cycle. And he has proved one formula. That formula is period equals to c into distance raised to 1.5. The c is nothing but it's a constant value. Distance is always measured in terms of kilometers. And whatever the period, the timing is measured in terms of seconds, in terms of second. Now, suppose we assume that, suppose we have installed one satellite at the height of 35,786 kilometers above the Earth. Then how much time it takes to complete a single cycle around the Earth? So it can be calculated by using this formula. So the formula is c. C is the constant. Its constant value is 1/100 into distance. So what is the distance? Distance is already given. So this distance is 35,786 plus this is the radius of Earth, 6,385 378, that is a radius of Earth. So that we need to add into the distance from Earth station to satellite, right? So but we have to add these two values. So this is 42,464 as to 1.5, and in total your answer means our answer would be 86,579 seconds. Once we convert it in the form of hours, then it's 24 hours. That means if we launched any satellite at the altitude of 35,786 kilometers, then it takes 24 hours to complete a single cycle. And this formula has been proposed and proved by Kepler, and that's why it is known as a Kepler's law. Now there is a one important terminology. It's a bent pipe. So bent pipe means what? So as I said, whenever we want to transfer a data from Earth station to satellite, at that time what happened? Suppose you consider this is one of the satellite, and this satellite, it is having transponder. Actually this is known as a transponder. So single satellite is having multiple transponders. Now what is the role of these transponders? You can see this is the sending, this is the one of the sending Earth station. So from this location, from this Earth location, we are transferring data into the upward direction, and this distance is 22,000 miles, right? So after traveling this much distance, the signal becomes weak, and that weaker signal is received by the transponder. Now inside this transponder, it uses a repeater, and repeater is used for the regeneration of that signal. So after receiving a weaker signal by this transponder, it regenerates the signal. And after regenerating the signal, it changes its frequency, because in a satellite, there are two types of frequency sets are used. One frequency that is for upward, it is known as an uplink, and second is a downlink. Whenever we want to transfer data from Earth station to satellite, it is known as an uplink. And for the uplink, we have to use some different frequency. And whenever we are transferring the data from satellite to Earth station, that is known as a downlink. But again, for the downlink, the frequency should be different to avoid interference between uplink and downlink. So this transponder, it regenerates the signal. After regenerating the signal, it changes the frequency. And after changing the frequency, the signal will be transmitted into the downward direction. And finally, it received by the receiving Earth station. And this entire operation, that operation is known as a bent pipe operation. So bent pipe operation is nothing but receiving a weaker signal, change its frequency, and after changing the frequency, it will be transmitted into the downward direction. That entire process, it is known as a bent pipe operation. Now next, footprint. Footprint means what? Footprint is nothing but the satellite, the signals which comes from the satellite always focused on some specific area on the Earth, and that specific area, that is known as a footprint. For example, suppose our Indian government, for example, suppose ISRO has launched some satellite, right? So that satellite that's focused on the India. So India would be the footprint for that satellite. So footprint is nothing but the location on which the satellite is focused. That is known as a footprint. Now, based on Van Allen belt, satellites are categorized into total 3 categories. So first I will explain you what is the Van Allen belt. Van Allen belt is nothing but it's a special kind of a belt which contains very highly charged particles. You can see in this figure, this is the area, this belt, it's a lower Van Allen belt, and this is the upper Van Allen belt. So this upper and lower Van Allen belts which contains very highly charged particles. So we cannot launch satellites in this region. If we try to install satellites within this region, then the satellites will be destroyed. And because of this two lower and upper belt, the altitude, they are categorized into total 3 categories. First category, that is below lower Van Allen belt. So this portion, this part is known as a LEO. LEO is nothing but low Earth orbit. The second component, that is between lower Van Allen belt and upper Van Allen belt. So this region, that is known as MEO. It's a medium Earth orbit. and the component, the portion which is above the upper Van Allen belt. So this region that is known as a GEO, it's a geosynchronous Earth orbit. So because of this two Van Allen belt, it is divided it into the total three categories: LEO, MEO, and GEO. Right. So this is the total altitude. This is a distance from the Earth station. If our satellites is launched between 20,000 to 35 altitude, then that satellite, it's a GEO satellite. And this is a range for MEO, and this is a range for LEO. Now, in this figure, you can see this is a GEO. Now, for a GEO, the distance is for 20 to 35,000 kilometers. So as and when we increase the distance of satellite from the Earth, from the Earth surface, at that time its footprint area will be increased. So here the distance is maximum in case of a GEO, and because of this large distance, right, because of this long distance, this much portion of the Earth surface it's covered by the GEO. Now instead of GEO, if you are using MEO, so the distance is reduced between MEO orbit to Earth surface, and because of that reason, only this much part can be covered by the MEO satellite. Now again in the LEO, the distance is too less, and that's why only this much part this much part can be covered by the LEO satellite. So in case of GEO, we need only 3 satellites to cover the entire planet. That means if you want to cover the entire planet, we have to install only 3 GEO satellites. But if instead of GEO, if we are using MEO, so a footprint of MEO that is less compared to GEO. And because of this limited footprint, we have to use total 10 satellites to cover the entire planet. And for LEO, this is the footprint for LEO. Again, by using LEO, if you want to cover the entire planet, we should use total 50 LEO satellites. Right? So depending on distance, we have to decide that how many satellites are required. Okay, so for GEO, 3 satellites, for MEO, 10 satellites, and for LEO, 50 satellites are required to cover the entire planet. Now, as I said, you can see this is a GEO satellite, right? So in the GEO satellite, the distance is more, and because of that reason, here the footprint area it's more compared to MEO and LEO. So only with the help of 3 satellites, we can cover the entire planet, right? So if you want to transfer, for example, suppose here we are having an Earth station. So from the Earth station, we can transfer data to the satellite number 1. Now this satellite can transmit data to the next satellite, because this satellite again it is in a line of sight satellite. So data will be transmitted to satellite 1 to satellite 2, and from the satellite 2 we can transfer data to the specific Earth station, right, which is the footprint of a second satellite. So in this way we can cover entire planet with the help of only 3 GEO satellites. Now next, geostationary satellites. So what are the advantages and what are the disadvantages of a GEO satellites? So as I said, we need only 3 satellites. So that is the advantage. But what is the drawback with the GEO satellites? The distance, the altitude from the Earth surface, it's more compared to MEO and LEO. So whenever we are using a GEO, and when we transfer any data from the Earth station, at that time it takes 270 milliseconds to and fro. That means suppose I said hello, right, through my mobile phone. If in a mobile communications, if we are using GEO, then that signal has to travel for 35,000 kilometers, and again it has to come back to the 35,000 kilometers. And the total time required for to and fro, that is 270 milliseconds. And because of this too much large time, this application that is not suitable for an interactive communication, for an interactive application. So whenever we want to perform any real time of communication, at that time this one is not suitable. And that's why the geo satellites, it is not used for the microwave, sorry, it is not used for the satellite communication. So this is the one of the drawback. The second drawback, geo orbit is already overcrowded. And in a geo, you can see this, suppose this is our Earth surface, right? And the Earth surface, it is having total 360 degree. Now, all the geo satellites must be separated by gap of 2 degree. So the total number of degrees 360 divided by 2, because there should be a 2 degree gap between two adjacent satellites. Okay, so we can install 360 divided by 2. So maximum 180 satellites that we can launch. And currently it's already overcrowded. There is no any space to launch some additional geo satellites because it has been already packed. It is already crowded. And these geo satellites, that is specially used for TV channels. And it is also used by the government and military satellites for the communication purpose. So this is about GEO. Now, the first artificial satellites, its name, it's Telstar. So Telstar, it was launched in the year 1962. And there is a one ITU. ITU is the International Telecommunication Union. This ITU is the authority, means we have to take permissions from the ITU to avoid any kind of chaos in the sky. Okay, and each and every satellite, normally the satellite's weight, it's up to 4,000 kilograms, and it consumes the electric power. And for electric power, it uses a solar panel. With the help of solar panel, it gets the energy, and it is in it would be in a working mode. Now there is one more terminology, that is station keeping. Station keeping means what? Whenever we launch any satellite, then that satellite should be in a orbit. It should not be come out from its orbit. And if it is moved from the orbit, then there is no meaning of that satellites, right? Because whatever the communications with the Earth stations, it will be lost. So the satellites must be in its orbit. And this task, it can be done with the help of on-board rocket motor. So rocket motor, it is responsible to keep that satellite in its own orbit. And this method, this procedure, this activity, it is known as a station keeping activity. And in the onboard rocket motor, they are using a fuel. That fuel is a liquid hydrogen. And whenever the liquid hydrogen, once it's exhausted, at that time, that satellites, it means automatically the satellites will be turned off. And that satellites, it's re-enter inside the atmosphere, and then it burns up, right? And normally the life of satellite, it is of 10 years. And the ITU, ITU has already allocated a frequency band to the different satellite users. And they've decided total 5 different bands for the communication purpose. So in this table, you can see there are total 5 bands: L band, S, C, KU, and KA bands. Now, first band, that is a C band. So actually the C band, it was the first band. It was used for the commercial satellite communication. And in the C band, as I said, there are downlink and uplink. Okay, so the downlink for the C band, it's a 4.0 gigahertz, and the uplink is 6.0 gigahertz. And the total bandwidth, it is 500 megahertz. Now, what is the problem with the C band? So whatever the frequency bands that we are using for the C band, the same kind of frequency bands are also used for the terrestrial microwave communication. And because of that reason, there is always interference problem with the terrestrial microwave communication. And again, the C band is already overcrowded. Then they proposed two additional bands in the year 2000. It's a L band and S band. So this is the frequency range for the downlink. It's a 1.5 gigahertz, 1.6 gigahertz for uplink, and the bandwidth is 15 megahertz. Then third band, it's a S band. Again, 1.9 gigahertz, 2.2 gigahertz, but here the bandwidth is increased from 15 to 70 megahertz. But again, the drawback of L band and S band, it is having low bandwidth and it's already, both are already crowded. Then the proposed next one, it is a KU. KU is nothing but K underband. Okay, K underband, it is not congested. Still there is a space. And what is the main advantage of a KU band? As I said, in Geo satellites, there must be a gap of 2 degrees between two adjacent satellites. But whenever if we are using a KU band, then that gap is reduced. So that gap is only of 1 degree. And because of a 1 degree gap, we can install double number of satellites. So that is the advantage of a KU. But again, in a KU band, it's always affected by during the rainy seasons, because the signals would be absorbed by raindrops. So that is a drawback of a KU band. The next band, that is KA. A is nothing but above, right? So K above band. K above band, it is used for the commercial satellites traffic, but again, it is very expensive. And additionally, along with the KU and K band, there are few bands are available that is specially designed for the government bands and the military bands. Next, LEO band. So first is Geo, second is the LEO band. Now, as I said, for LEO, we need total 50 satellites to cover entire Earth. Okay, but in case of Geo, we want only 3 satellites. Still, people, they prefer LEO. So what are the reasons? Why the LEO is attractive? So these are the few reasons have been given here. Number 1, Geo, it's already overcrowded. It's almost full. There is no any space for the installations of new satellites in the Geo orbit. Second one, LEO, that is nearer to Earth's surface. And because of that reason, we need a less amount of strength, limited strength. Even if the signal is having a limited strength, it can easily travel up to the LEO satellite. Because, for example, suppose you consider our mobile phone, right? So our mobile phone is having very small battery. So it cannot emit a very highly, the strength of that signal is very less in case of a mobile phones. But still, it can travel. The same mobile signals can easily travel up to LEO because the distance is very less compared to Geo. Okay, so we need a less amount of power for communications with the LEO satellites. How much time do we need for LEO communication? So we need only 1 to 7 milliseconds. In case of Geo, it takes 270 milliseconds. But now here it takes only 1 to 7 milliseconds. And because of that reason, this one is used for interactive communication. So whenever we want to perform any real-time applications, at that time, this is a most suitable solutions for communication purpose. Now, LEO, it is less expensive. We can easily launch the LEO compared to GEO. So these are the few reasons. And because of that reasons, the LEO is also in the demand compared to GEO. Now here, the name of two satellites are given in this slide. One is a GSAT-16. So GSAT-16, this is one of the satellites launched by ISRO in the year 2014. And the weight of the satellite, it's a 3,181 kilograms. And the total number of transponders used in GSAT-16, it is 48 transponder, right? And this is the 8th satellite launched by the ISRO. And the main objective of the satellite, it's a communication service, to provide a communication service to India. During the same period, means in the year 2014, the NASA, they launched one more satellite. The satellite's name is a OCO2. It's an orbiting carbon observatory 2 satellites. And normally the satellite has been specially launched to monitor the atmospheric carbon dioxide, because we already know that we are suffering from the warming issue, right? Global warming issue. And for that purpose, the NASA, they launched the special satellites for monitoring the carbon dioxide level. What are the advantages and disadvantages of the satellite communication? So the advantage, that means in a broadcast communication, the satellite is cheaper compared to fiber optics cable. So it is less expensive. And the second advantage, the mobile communication, it can be done only with the help of either satellite or microwave communication. We cannot use a fiber optics cable in case of mobile because it's a mobile. We are not using any physical cable, right? So we cannot perform mobile communications by fiber optics cable. So we have to use either satellite communications or microwave communication. What is the disadvantage? Installations of satellites is very expensive. And what are the applications? So it is used for global communication, for mobile communication, even military communications, government communications. These are the various types of communications that we can perform with the help of satellite communication. Now, here the comparisons between satellites and fiber optics is given. So we already know that now the company, they replacing the existing coaxial cable by fiber optics cable, right? Because fiber optics cable, we can achieve very good data transmission rate compared to copper wire. And in fiber optics cable, the data rate is also very fast compared to twisted pair and coaxial cable. And even the broadcasting, it's much cheaper compared to fiber optics cable. Now, in mobile communications, whenever we want to perform a mobile communications, at that time we are having only they are having only two options, that is satellite communications or microwave communications, but we cannot use any guided communications for in a mobile communication. The next benefit, in some of the undeveloped area, when the installations of fiber optics cable, if it is not possible, then only we can use the satellite communication. Now, if we want a securely transfer data, at that time we should use wired communication, because wired communication is more secure compared to wireless communication. But even in the wireless communications, if we use some kind of encryptions algorithm, right, then we can also transfer data securely. But still, the wireless communication, it is less secure compared to wired communication. And at the time of war, the military always prefer a satellite communication. They are not using a fiber optics kind of communications, right? Because the location is not fixed. And that's why at the time of war, the satellite communication is always preferable. Now, these are the spacecraft launched by the ISRO during last 3 years. So this is the first one. You can see this is a GSAT-30. It was with this satellite. It was launched in 2020, and it is specially designed for communication purpose. After that, EOS-01, right, in the November 2020, and it is specially designed for disaster management system and Earth observation. Afterwards, again in the December 2020, CMS-01 satellites was launched, and again it is used currently it's using for the communication purpose. Afterwards, the fourth satellite, its name is EOS-3. Okay, and the objective was Earth observation, but it was not launched successfully. Then the next is EOS-4, and EOS-4, it was launched in the year February 2022, and again the application is Earth observation. And the recent, it's February 2022, and its name is INS-2TD, and again it is used for experimental purpose, right? So this is the list of satellites launched by ISRO during last 3 years. Now, in this figure, you can see actually this survey has been done by Start Us Insights, and this company, they surveyed total 1,361 startups and emerging companies. After analyzing this many companies, they have published one report in the November 2021, and they identified top 10 satellite technology trends and innovations in 2022. So the satellite technology, which includes small satellites, then satellites IoT, then in-orbit service, advanced ground systems, artificial intelligence satellites, advanced payload systems, the spacecraft propulsion, very high throughput satellites, new launch services, additive manufacturing, right? So these are some of the not some of these are the top 10 satellite technology trends in the 2020-22. And how much they contribute, that ratio is given here. You can see the impact of each and every 10 technologies have been given here. So small satellites, its impact is 20%. Satellites IoT, it's a 14%. Advanced ground system, it's a 11%. AI, it's a 10%, right? So each and every is having some kind of impact on a top 10 satellite technologies. So dear participants, as per requirement, you can use either guided media or unguided media, but guided media, that is preferable whenever you want to transfer a secure data, whenever the installation is possible. But if the installation is not possible and if we don't want to use any kind of physical media, at that time we should go with the unguided media. And for a long distance communication, satellite, that is always preferable solution. So this is about satellite communications or transmission media.
So participants, if you have any doubts, you can raise your hand or you can type in the chat box so that I can unmute you and you can ask your questions.
Okay, no questions. So I hope.
Thank you so much, madam.
Yeah. Thank you, sir. Thank you so much for inviting me, and I hope that the students are satisfied with this content.
Yes, madam.
Yeah, thank you so much.
Thank you, madam. So all of you, feedback form is posted in the chat box of the Zoom and as well as in the YouTube. You can fill it. Those who have filled the feedback form can leave now.
Can I leave, sir?
Yes, madam. Thank you so much, madam.
Okay, thank you.
Thank you. Participants, all of you, please fill the feedback form first. Those who have filled the feedback form can leave now.